students feel this connectedness with their work. They don't even realize that they're doing math and science because they're having so much fun.
Our goal is to have this experience, change their thoughts about what they can do in the future.
At STARBASE, we serve students in 4th, 5th, and 6th grade, and during the school year we take students from Minneapolis and St. Paul public schools primarily, and then in our summer we have a special program where we serve different corporations from around the Twin Cities that are involved in STEM.
STEM is science, technology, engineering, and math, and the core behind STEM is that these subjects are taught as interdependent subjects. While students are conducting experiments, they're actually using math to look at the data, to analyze the data and solve the problems. They're learning some pretty sophisticated physical science concepts. They're also learning about design and engineering, and it's all done in an integrated fashion. The program is designed with the end point in mind. It's what do we want the kids to walk away with, and that's a love of science and engineering and of technology, an understanding of how math actually helps us solve problems. The particular theme of this program that you see here today is designing a mission to Mars. So the students are presented with a problem. Well, we want to land on Mars in 2035, a human mission to Mars. How are we going to be able to do that?
We can take them from these math, science applications of concepts into how they can really impact their decisions, and then hopefully that will let them see that this is how people are doing work in the real world.
The 6th grade program, they design their own fins on CAD and then they print them off on an dimension printer. So they actually get to launch the fins that they've designed on CAD, which is pretty cool.
3D printing has been really cool for our program because we're always trying to make our engineering activities and our science activities actually applicable, how that they can actually reflect some change in the design. The kids saw it today. There was a bunch of really big surface area fins, and then there was one that had hardly any surface area at all, and it just tumbled, so they could see the result of their engineering decision onto a 3D model, and then the result in kind of the real world test.
Our 3D dimension printer has helped us immensely with our summer program and school year programs. In the summer, it's created an opportunity for students to be really connected to their design because they can design it on the computer and actually print it out, a physical model they can touch, feel, test on a model rocket. During the school year, we as instructors have used it when we get equipment that doesn't work quite like how we were expecting. We can just design something in CAD, print it out, and now the equipment can work exactly like we need it to. So it's been a pretty good addition to our program.
People are hungry for this, students are hungry for this, and schools are, because it's a really well-crafted curriculum. It's aligned with state and national standards as well. It's really getting them excited about engineering, seeing science as a way to solve problems, allow them to work in teams, give them a story to follow, kind of a piece of the puzzle to kind of get them to the end goal.